Hey guys, it's Micah with the Modern Einstein. Today I'm going to be doing a science segment. We're going to be talking about physics today, and we're going to analyze some different forces that are exerted. And we're going to start a force unit here, and we're going to be doing some different demonstrations. But first, let's introduce the main forces that we have. We have a force due to gravity, which is the force that the Earth exerts towards that is exerted towards the center of the Earth. We have a normal force, which this is actually the force that an object exerts on you. So if I'm standing on the ground, that ground has to support me, and the force that it's putting on me is called the normal force. We have an applied force, which is when we push something so it'll move. We have a tensional force, which is when something's pulled and there's tension in between it. We have a buoyant force, which is like a water and styrofoam kind of thing. And we have several different forces here, and we're going to do some demonstrations. So let's get to that.
Pauses.
Okay, this could be a demonstration of about at least two forces. First, we have a gravitational force that, of course, the Earth is applying on me, and we have, of course, that's affecting my shoulders right now very much, much affected by the weight of him on me, and another one is my shoulders have to support him, and that would be a normal force. And as long as he's suspended up on my shoulder is applying a normal force on him. Another one would be my feet. My feet, they apply a force on the ground, and the ground applies the normal force on them. Because I'm not falling through the ground, there is a normal force which is supporting me. If we didn't have normal force, then I'd either be crashing to the ground or flying through the air. And you can see we're pretty stable right here. Well, for the time being anyway. Okay, so now we're going to demonstrate an applied force. This is when I'm acting on a force and I'm physically pushing on an object. Kind of like this. That would be an applied force. I physically pushed him and he fell. So remembering, a force always results in a change in velocity. Whether that be zero or even if he stands still, as long as the velocity changed a little bit, there's a force exerted. And you can see the result is Carson being covered in grass and dirt.
No, just dirt. Get out.
Okay, so that's been a demonstration of the tension force. Now, a tension force is different from an elastic force. A tension force doesn't stretch at all. So you can see I have a force applied at this end and a force applied at this end. And it just results as a tensional force. So the word for word definition would be something like an object being pulled taut by both ends. So that's a tensional force, different from an elastic force. Okay, now we have an elastic force, different from a tensional force. This allows me to do stuff like this. So an elastic force is the stretching. It allows it to be stretched. Also like a wristband or something like this. So when I pull this, it stretches and see it pops back up. The reason it pops back up is because it has the tensional force, or elastic force. So when I pull this, it creates a force that resists it. And that's why we can shoot the rubber band like that. Because when you stretch it, it creates a force that wants to go the opposite way. Whereas a tensional force, we can stretch it as much as we want, let go, it's not going to do anything. So difference between tension and elastic. Okay, so now we're going to be talking about frictional forces. This reacts when a force is applied between two surfaces. So if I'm going this way, the friction force opposes the acting force. So if I'm pushing this way on an object, the friction is going to go this way. Carson's volunteered his head, so we're going to see how his face reacts with this wooden pole. You
What?
ready?
What? You never said
Yeah.
anything. What?
So pay attention to his head. Okay, thanks, bud. You know, he's always willing to give himself up for science.
I have splinters everywhere.
Anything in the name of science, right? So, what was happening besides the fact that I was torturing his face? So,
picking my nose.
as his head was sliding against this splintery wooden pole, not only was he getting splinters lodged in his head, but there is a friction force. So when I pushed down, the frictional force resisted his head, and it went up. When I pushed up, the friction force went down. So, anything in the name of science.
There's a splinter in my eye.